I'm going to leave that up to you to give me feedback about where you stand on this particular thing. Okay, so what we have here in section 3.3, we're going to talk about quadratic equations and inequalities. Okay, so one of the new situations we're going to use our ability to solve a quadratic is to solve inequalities. That comes up every unit with the new functions we're talking about. So again, hopefully this is something that looks pretty familiar to you. I've got my quadratic equation is something that's ax squared plus bx plus c equals 0. Okay, it's key that we have this equal to 0. And then the same thing I said before, a, b, and c can be any real numbers. And then a has to be not 0 because we want it to be a quadratic. If a is equal to 0, then you've just got a linear equation, a much easier situation to deal with. So the first couple of problems that we're going to do involve solving by probably the first method you ever learned, which is factoring. Okay, so just a couple quick examples. So in mine, x squared minus 8x minus 20. I'm going to factor that trinomial. So again, as I mentioned before I started the video, I'll mention this again. And for anybody on the video, if all of this is not review for you, factoring trinomials, solving quadratics by factoring, send me an email. I've got stuff I can give you to help you out, but we're just going to kind of jet through this. So x squared is x and x. The two factors of negative 20 that are going to add up to negative 8. Anybody want to help me with that? All right, so negative 10 and positive 2, those multiply to give me negative 20, and they add up to give me negative 8. Then we're going to use something called the principle of zero products. And all that says is when you have two unknown numbers, I don't know what x minus 10 is. I don't know what x plus 2 is. But I do know when I multiply them together, I get 0. So because of that, I know that either x minus 10 equals 0 or x plus 2 equals 0. One of those two things has to be true. So in this case, when I add 10, I get that x is 10. In this case, when I subtract 2, I get x is negative 2. So there's my two solutions. I'm going to save us time, but you could plug those in and check them and see that those are the appropriate answers. So for exercise 1, I'm going to give you a moment to do that, but just a little hint so we're all doing the same thing. Before you can factor exercise 1, what do you have to do first? You got to bring that 24 over to the other side by subtracting it. Great. Thank you for being alert and astute. All right, so I'm going to subtract the 24 over. So I've got x squared plus 5x minus 24 equals 0. I'm going to factor this now. X squared is x and x. The two factors of negative 24 that add up to positive 5, what are those going to be? Yep, 8, positive 8 and negative 3. Those multiply to give you negative 24, and they add up to positive 5. Now I will use the principle of zero products. And x plus 8 equals 0 or x minus 3 equals 0. That gives us these two solutions, either negative 8 or 3. So my solution set is negative 8 and 3. All right, the next problem. Notice I've got a problem that I'm going to factor, but this time I've got a number in front of the squared term. Now, I know many of you, all of you come in here with different math backgrounds. I don't care how you factor something with a number in front of the x squared. Okay, I know there's like 4 or 5 different methods you could use. Some of you are probably good at it. Others of you are probably not. When I show my intermediate algebra classes, just because it always works every time and it's similar to what we just did, is I show the AC method, okay, which is the completing the square method. So if you have another way, you do not have to do my method here. You can factor it right now at your seat and we'll meet up at the end of the problem. But in case you've forgotten how to do this, here's what the completing the square method is. First, you multiply the A and the C value. And so 2 times negative 21, I'm just going to write this over on the left, is negative 42. Here's my scrap work. Now I need the 2 factors of negative 42 that add up to negative 11. So since it's a negative 42, I know one's going to be positive, one's going to be negative. And the 2 factors of 42, I don't know them off the top of my head. I just got to kind of mess around here. 42 is 7 times 6, but those are only 1 apart, not 11 apart. So that doesn't help me very much. So what I'm going to do is I'm going to take the factor of 2 from the 6, and I'm going to give it to the 7. So 2 times 7 is 14 times 3. And 14 and 3, they are 11 apart. So that's the pair of factors I want. I want the 3 to be positive, the 14 to be negative. So let's check that out just so that we don't move on and have the wrong answer accidentally. 3 times negative 14 is negative 42. And then 3 plus negative 14 is negative 11, which is the number in the middle I need. Now, what I do with those numbers, I do something a little different than I did in the previous 2 problems that had a 1 in front of the x squared. I use that to now set this up as a grouping problem. Again, you are not bound to do this by the grouping method if you have a different method. If you were in my intermediate algebra class, this is what I taught. If you have no method because you've forgotten, again, email me. Okay, do not just sit there in ignorance. Let's get this down pat because you are going to use this. You are going to have to know how to factor things. So the grouping method says now I'm going to just look at the first 2 terms and the last 2 terms. I'm going to group them. I can factor an x out of the first 2 terms and have 2x plus 3. I can factor a negative 7 out of the last 2 terms and have 2x plus 3. My grouping worked because I have the same exact thing in parentheses, so I will factor that out. And when I factor the 2x plus 3 out of those 2 terms, I have x minus 7. Again, I'm just jetting through this problem. I'm just reviewing with you. So this is the last time I'm going to say it because I know you get tired of me. If this is not review, you need to talk to me, please. Okay, so I'm going to set both of these now equal to 0 using the principle of 0 products. And I get my 2 solutions. My first solution, when I subtract 3 and divide by 2, is negative 3 halves. And the second solution, when I add 7, I get 7. All right, so I would like you to do exercise 2. It's another one that will factor, I promise. Please solve it. All right, just for time's sake, I'm going to get started. So I'm going to again do the grouping method. So if you did this a different way, fantastic, I love it. So 3 times negative 12 is negative 36. So I need the two factors of negative 36 that are going to add up to negative 16. And so that is they're going to be one of each. I need a positive, I'll need a negative. Again, I don't know this off the top of my head. Maybe I just figured it out why I was saying that, but so if I had 9 times 4 is 36, but those are not 16 apart. Okay, so I'm going to take 2 from the 4 and I'm going to give it to the 9, so that's 18 times 2. 18 times 2 is 36, and those two numbers are 16 apart. So I'm going to make the 2 positive, the 18 negative. So now I'm going to set this up as a grouping problem. So I have 3x squared and then plus 2x minus 18x minus 12 equals 0. I'm going to factor the x out of the first two and have 3x plus 2. I'm going to factor a negative 6 out of the second two and have 3x plus 2. And I'm going to factor that 3x plus 2 out. So what's left from the first term is x. What's left from the second term is negative 6. The principle of zero products says 3x plus 2 equals 0 or x minus 6 equals 0. So when I subtract 2, divide by 3 right here, I get negative 2/3. And when I add 6, I get 6. So my solution set is negative 2/3 and 6. So please practice that as part of your homework. Okay, we're not going to get through section 3.3 today. We're just going to do one more type of problem. We're not even going to do the quadratic formula. We will pick up at the quadratic formula next time. Okay, but practice solving things. So the last thing we're going to do today, you missed that I said we got one more quick little thing. Sorry to be buzzkill there. All right, so the last thing is sometimes our quadratics are set up in a nice way that we can solve real quick. So in these next 3 problems, we have problems that are given to us in a special format. Okay, so we've got a special format. So if you have a problem in this sort of format, there's a shortcut that you can take, or you're welcome to multiply everything out and either factor or use the quadratic formula when we talk about it. But when the special format is if I have something squared equal to a number. So something squared equal to a number. So you can see example 3 that I'm going to do and the other 2 exercises right next door. They're all in this format of something squared equal to a number. When that is the case, here's what you can do to solve. I've got x plus 2 squared equal to 13. What I'm going to do to both sides of this is I'm going to take the square root. So I'm going to have the square root of x plus 2 squared is equal to the square root of 13. Now, if you employ this method, if you notice you have something in the format of something squared equal to a number and you do this, you have to remember this one thing. Okay. If I was to go backwards, what we're saying is this is equivalent to this. If I was to go backwards, I would have to square both sides. And there are 2 things that I could square to get 13. I could square a positive square root of 13, but I could also square a negative square root of 13. So there's actually 2 answers that we are generating. So know this as a general principle. Anytime you impose a new square root on a problem, you are then going to have to put in a plus and a minus. Okay? If the problem starts off with a square root, you don't have to do that. But when you use the square root as a tool, you have to now do that. So on the left side, the square root of x plus 2 squared is just x plus 2. On the right side, the square root of 13 doesn't simplify at all. So I just have plus or minus the square root of 13. I'm 1 step from the finish line on this problem. I'm going to subtract the 2 from both sides, and I get that my solutions are negative 2 plus or minus the square root of 13. Now, when I write my solution set for this, I'm just going to write the solution set of negative 2 plus or minus the square root of 13. But I have a bunch of students that like to write like this, and I have no problem with it. Or you can write this as your solution set, negative 2 plus the square root of 13. Comma, negative 2 minus the square root of 13. Okay, some people like to separate the 2 answers just to see that there's 2. That's fine. I have no preference either way. Okay, so we're just going to do one more problem and then we'll pick up from there. Exercise 3. Go ahead and solve exercise 3 using this special format. We'll check our work and then I will release you for the day. All right, so since I have it in the format, something squared equal to a number, I'm going to now go ahead and I'm going to take the square root of both sides. So I'm going to have the square root of x squared on the left and plus or minus the square root of negative 36 on the right. On the left, the square root of x squared is x plus or minus. Here's a quick little review. When I have a negative under the radical, what kind of number do I get as a result? You get an imaginary, an I, yeah, the imaginary unit. So I got an I, and then the square root of 36 is 6. So your two solutions here are plus or minus 6i. When we get back together next time in the next video, next class, we'll start off with exercise 4.